We're going to have a detailed look at the management server. Some pages I'll gloss over, but some others will be in greater detail than what's in the PDF. The management server is enabled and running by default when you program the controller, and you use the management server to configure or change the configuration of the focuser. When you need to troubleshoot, the management server can give you lots of clues about what's going on. And a lot of the management server pages have descriptions of settings when you move the cursor over them. So let's start from scratch. We'll do the modification of the config.h file and other settings that need to be changed. Then we'll compile and upload the firmware, upload the file system, and you'll be able to see what the state of it is when we actually start it up. Right, so here we have I've got the Arduino IDE uploaded. I'm using current firmware, and I'm into config.h, and of course I set the focuser, I set the fixed step mode, steps per revolution. I then decide that I'm using station. And in station configuration, there are define station defines.h. I'm using static IP, so therefore I need to go and have a look at this file. Right, so here we are. I've got a folder open to the current firmware, and I need to have a look at station defines, so I'll load that up. And this is my home network for an observatory, and here I've configured the controller to be a static IP of 192.168.0.142. So that's going to be sent to the router that is running the network 192.168.0. So after having a look at station defines, we are using read WiFi config enable, and that's a JSON text file, so we better go and look at that. Right, so I'm looking for the read WiFi config file because it has to be in the data folder, and I can load this up, and it specifies my home Wi-Fi where all the telescope gear is. So that's okay. We're winding our way through. Enable DNS, and remember the web server has to be running for MDNS to work. I've defined OTA servers, I defined a text display, I defined duckdns, and so those are what are in the configuration file. And even though I've defined them here, like MDNS OTA update, even though I've defined them here, remember that the default configuration is going to include these things. These will be added, but the default state of all these things are they're not enabled and they're not started. So we will next we'll do the upload and then upload the data files as part of the file system, and at that stage we'll come back. First up is the servers page, very first one in the list, and you can see that the default state of Alpaca server is disabled and stopped, same for the debug server and the same for the web server. Now remember that I enabled MDNS, so that won't be running because it needs the web server to run. So this should be enabled and we should be able to start it. In terms of the debug server, if you've enabled debugging in any of the classes, then obviously this needs to be enabled and started. but I'm going to do a video just on debugging and help, so I'll cover it then. There are some new things associated with the debug server and TCP server. We now have a timeout facility, and more about that in another video. Here we are with the display. What you see on this page in the management server, and I got to it by clicking on display. The contents of this page varies depending upon what type of display. And so currently I've defined text display, so I also get a thing called brightness, 0 meaning it's basically not on or blank, and 255 being the maximum value of brightness. And I could type in particular figures, but it's of course a range checked between the two boundaries. And if I hover over brightness, it tells me what those values mean. The page display options, well, there's a number of pages set up that is cycled through on the display. So once it's finished one page, it goes to the next available page. When it's finished with temperature settings, because display settings is not enabled, it goes straight to presets, and from presets it's going to go back to the very first page, and these can be turned on and off at will. All right, so it's easy. It's an easy way to manage a display. Now just remember that you might have a focuser which hasn't got a display yet, and so if you're going to add a display, this is how you set up and initialize the display to what you want. duckdns. This allows you, it only works in station mode, but it allows you to set up a remote IP, which then you can use from anywhere in the world to access your focuser. So this is ideal for remote observatories. And if you've got this enabled in config.h, then this is what you will see. When you go to duckdns first, create a domain name, and they'll give you a token. Come back in here and you enable it, etc. Refresh time is how many times does the controller go out, speak to the duckdns server, and then get back an IP address. This IP address, once it's assigned there, should be relatively permanent for the session, but it may vary from session to session. So that's duckdns. So it tells me what controller mode I'm on. That's purely information that I've got a static IP enabled. The device name is what you call this focuser, and I've named it as this, but it can be changed at any time. You just type the new one in and it changes. And then this one here, use device name as a host name, will allow you to use this name to access the controller. This can be enabled or disabled. The default state should be disabled. The MDNS Name comes from the defines field. The value for MDNS Name, which I currently got set to Bob's Focuser Pro 2, comes from the apps define file, which sits underneath the firmware/defines folder. And you would normally set this up. If you forget to do this when you're programming the firmware, it's not a problem, because you can see here you can change this at any time. Reboot delay is if we have to reboot something, how long do we normally wait first? There are various web pages, and you can individually set these things. So if I change this to, and let's change this one here. All right. I just like to use uppercase. The first two digits are red, next two green, and the next two FF RGB. So red, green, blue. And if I hover over here, it says don't put the hash in front of the color information. So this is color information, and if I did that, that's invalid. So you don't want to do that. And of course, we had got things here to handle color schemes, and you can enable a particular color scheme when the controller boots, and you can change your color scheme by making some values, select a particular color scheme and just go save. The temp page, last on the first row, allows you to control settings related to temperature, and remember that temperature probe is part of the default configuration, and from a firmware upload followed by a file system upload, this is what you will see, and all set to defaults. And so the default state is it's disabled because you might not actually have it connected, and unfortunately the firmware doesn't know that. So the status is definitely stopped. You can change from Celsius to Fahrenheit just by doing that. And notice this value changes as well. The resolution is in terms of the value that's sent back, how many digits are involved. It doesn't mean accuracy, it means the range of the temperature band within what you're looking for. So this temperature range goes down to 0.25 of a degree, and that can be changed at any time. The temp comp is temperature compensation, and in the early days of the Focusers, what used to happen was you could work out what the difference in focus change is. Like if there's a 1 degree drop in temperature, you could work out that the position of the focuser had changed by, let's say, 100 or 120 steps. And so that was always handled by the focuser. Today, with intelligent focuser applications, things like Nina, they can handle all of this for you. When a client connects, one of the first things they do is they ask for TC available. Is the focuser capable of handling temperature compensation? And so if this figure is true, and it's true if a probe is detected. If a probe isn't detected, it will always be false. And also you can turn the state on and off here rather than have a client application handle it. So for example, if you have ESCOM Focuser and you want to make sure that the state, TC state, is actually true before you connect your ESCOM driver, what you could do is you could come in here, set it, and then when the ESCOM driver started, it would find TC already enabled. The backlash is quite straightforward. Again, there are client applications out there which can calculate your backlash and try and compensate for it. There are many different ways to handle backlash, and in the client application like Nina, it can manage backlash for you, but in my opinion, it doesn't do what it should do. All right, so when you look at a focuser and you move one way, when you reverse direction, go back the other way, there's a state where you've got a few motor steps, but the position of the draw tube, etc., hasn't changed at all because it's taking up all that slack in the gearing system. That actually means that the focuser position has not changed. And the problem with things like Nina is they make a guess and they say, oh, I'll go 50 steps or 100 steps past and then I'll reverse and that will take up all the backlash. But that's not really the correct way to do it, because again, when you reverse direction, the focuser position is not actually moving at all. It's just you're taking up the slack in the gears, etc. So I prefer to handle backlash using the ability of the focuser. And once you've got that set up, this is a breeze. All right, so if you were to set it up, you would do the calculations. You'd find out how many, if you're doing backlash in, first thing you do is you move it out, say 100 steps, and then you'd move it back in one step at a time until the focuser actually started to move. The draw tube actually moved inwards. And then you work out how many steps it was, and you type it in here. Let's say it was 20, and you just go set, and you'd enable it. And you do the same for backlash out. Backlash out, first of all you move in, and then you gradually start moving out one step at a time until you see the draw tube actually change. Then you know how many steps you've gone, and you can type that in, and then you can enable it. So this focuser works on the basis that if it's backlash, the position is not moving, and therefore focus position will not move until such time as there is a movement in the draw tube. And I believe that that's a far better way of handling things in backlash compared to what some of the clients do. The home position switch is supported on every single board type. It is a physical switch except for the TMC2209, and you can easily test this within like the Windows app, or you can even view it on the home position page. For the TMC2209, you've got a choice of a no home position switch, a physical switch, or a software switch, which we call stall guard. And you can directly plug in what the motor current is. There's no fiddling around with some pot trying to get voltage or current right. And the firmware enables interpolation, which means that a single step, let's say one full step, can be broken down into 256 micro steps. If you're using a home position switch, whether it's a physical or whether it's stall guard, you have to make sure that it's enabled for a start. And notice this, it's a status open. So if I went out to the scope and I activated the home position switch, and then I clicked on the link again, that would say closed. So that's an easy way to test it. For stall guard, of course, you'll have to enable stall guard like that. And because I don't have the focuser in this is set to a dev kit TZT ULN 2003, so I can't really make any changes here to stall guard because the button's grayed out. I can't do anything. But for those that have defined it as a TMC2209, then the various options can be set.